questions up to where we're at. Just to give, I know that Otto, you were out. We missed you on Monday. Hope you're feeling better. We finished up talking about circles on Monday, and we moved on to something called ellipses. So we didn't finish up the ellipse section yet. That's what we're going to talk about today. But I just want to make sure before we dive in, and nobody had any questions. All right. Well, if you do, let me know. So I'm going to do something a little bit different today. And that is that I want to walk through a Desmos activity together. So I'm hoping you guys are game and that you're willing to participate in the chat, because I think it'll make it a little bit more interesting. And if I can figure out how, I want to, add that into maybe some extra credit on your test. So try to participate when possible. All right, so what this is an activity, if it will load. This is an activity in Desmos that I would like to go through. We're not going to go through every single part because it's not completely applicable, but I think it's a really good activity to understand circles and ellipses and their relationship to each other and all those words that we were talking about the other day. So I want to spend a little time going through this, and then we'll spend some time going through the problems. All right, so the first thing I want you to notice is, what is this shape right here? This shape, yep, there you go, Otto. It's a circle, right? Leah, and a circle. So, and this is what we learned about at the end of class. Yes, you are very smart. So it's a circle, and this is this equation on line number 2 right here. X squared plus y squared equals 3 squared represents this circle, okay? And that circle has a radius of what? 3, right? It's got a radius of 3. So it's the radius, it's x squared plus y squared equals the radius squared. So that's what we talked about on Monday, and we talked about how to find that radius using the distance formula. So now we're going to start kind of diving into an ellipse and how it's related to a circle. And I think this, walking through this in Desmos, will actually give you a much clearer picture of how they're two related. So what we're going to do is we're going to take this equation of our circle, and we're going to multiply this term by 3 squared. Okay, so we multiply the y term by 3 squared, just like we have our radius is 3, or our radius squared is 3 squared, right? Then you see that our circle goes from a circle to basically a stretched out circle, right? And this is close to what we're talking about with ellipses, right? Also, if we did the same thing and we multiply by x squared, it's going to stretch our circle, but a little bit differently. It's going to stretch the circle. If you multiply the x squared term by 3 squared, it's going to stretch the circle this way. So then you end up with a really cool looking shape on Desmos, right? But basically what this is showing you is that if you take the basic circle equation and you multiply either the y squared term by the radius squared or the x squared term by the radius, you get the stretching of your circle. So it stretches it out. But you'll see that if you want to call it the diameter of the long part of the ellipse, is still the same as the diameter of the circle. Either way, it's stretched. Okay, so we call these new figures are ellipses, and that's what we started talking about on Monday. Excuse me. Okay, so that's just kind of an intro. So you'll see here that they're just showing you that depending on what number that you pick, so if you have your equation of your circle, x squared plus y squared equals b squared, and then you add on this b squared to the x term, no matter what b is. So if you make, instead of that last circle was a radius of 3, if you make your radius 5, right? if you also multiply your x squared by 5 squared, your ellipse follows along the same. So you can see that there's this relationship. So that's what the second slide is about. Okay, and then this shows if the same thing if you multiply by the y squared term, then your stretching goes in the other direction, right? If we made this a radius of 6. Your circle has a radius of 6, and then if you multiply the y squared term by, whatever your radius squared is, then your ellipse also has, it's not really a radius, but it is similar to a radius of 6. So this is just kind of intro. How do we see ellipses? Okay. So, all right. So here's where you guys have to help me out. Who can tell me what the equation of the red circle would be? So tell me what the equation of the red circle would be. And we're going to type, once we kind of get a consensus, we're going to type it in the chat and see if we're right. So what would the equation of the red circle be? So remember, the circle is always has this equation, right? It's x squared plus y squared equals the radius squared. Okay, but what would the radius be for this red circle? 4, exactly. The radius would be 4, right? So if we put in here x squared plus y squared equals 4 squared, then we get the equation of the circle, right, Anton? Yep. So this is your equation of the circle. See how they wanted you to match it? You can write an equation. So now, I know I just did this really quickly, but if I take this same equation, okay, and I want to make the purple ellipse, so I want to make it stretch this way, I would need to multiply my x squared or my y squared by what number to stretch this out? 4, exactly. So, yep, 4 squared. I got that, Olivia. Oops, sorry. 4 squared. Okay, so I promise this is getting somewhere. So you see when you multiply one of the terms also by the radius squared, then you get this stretching, right? And then we're all matched up, and that's great. Okay. All right, and then this is another one where we would match our circle. This one is not in the center, so we're going to deal with things not in the center later. So we get to skip this slide. Okay. If you want to stretch your ellipse with a combination of 2 kinds of stretches, then your equation looks like this. So you're going to have to think in your brain a little bit. It's x squared plus y squared equals radius squared. That's your equation of your circle. But if you want to stretch your equation in the x and the y, you want to stretch it both ways, right? Your equation would be whatever your radius is. Let's say that your radius is, I don't know, in this case, what is it? Yeah, they have 7. They have a radius of 7. They're a radius of 7. So if your radius is 7, you could write that as 2 times 3.5. You could break that up, and then you can multiply each piece so that you're basically stretching your ellipse in the x and your y. Or sorry, you're stretching your circle out in the x and the y to form an ellipse and stretched in both directions. Okay, so let's think of something really simple here. What if I chose a radius of, let's see, 6? I like 6. Okay, and I'm going to print screen this so I can write on it. Okay, so my red circle right here, right, has an equation of x squared plus y squared equals 6 squared. That's the red dotted circle. That's my equation for that. I think everybody's good with that, right? It's got a radius of 6. It's at the center. Okay. So what happens if I take my red circle, okay, and I stretch it both in the x and the y? That's the question. So I can stretch it in the x. We did that before, right? And I can stretch it in the y. But what happens if I do both? So what I can do is I can think about this radius and say, well, I am going to think about stretching um, stretching in the x. I'm going to think about stretching in the x-axis by 2 and then the y-axis by 3. So 2 times 3 is 6. So I keep my same radius, right? But in order to stretch in the x-axis, I'm going to multiply my y by 2 squared. So you get 2 squared y squared. And I'm going to multiply my x by 3 squared. So I get 3 squared x squared equals 6 squared. And then if I do this, then my circle becomes this blue ellipse. Okay, I know it's a little bit confusing, but I promise we'll get there. So what this does is it gives me, this is represents my 2 and this represents my 3. All right. So if you go back here, these are sliders where you can change these values. If I wanted to change my radius to, let's say, 8, so I'm going to make it 2 times 8. See how this is 2 times 8, or 2 times 4 is 8, so my radius is 8. Then if I multiply this a term by y, then that represents, if I multiply 2 squared by y, that represents a stretch of 2 this way. And if I multiply my x squared by 4 squared, that represents a stretch this way. Okay, this is a little bit confusing part, but I promise we're going to come out on the other side. So can you kind of see how there's this weird relationship with this equation that if you look at what the radius squared is and then you take pieces out, then that's what stretches your circle in different directions. That's kind of the main idea. All right. So that's kind of what we're talking about, the movable points. Okay. So here is where it all comes together. And I know this looks like a confusing screen, but it's okay. So this is what we were just talking about, this weird equation where if you have some radius where you break it into 2 parts and then you multiply one of the parts by x and one of the parts by y, you get an equation that looks like this. Okay. If we do some algebra, and you don't have to do this algebra every time. This is just kind of like a proof. If we do some algebra and first we distribute this squared term, okay, and then we divide everything by a squared b squared, then we come up with this equation right here. And if you were at class on Monday, this equation should look really familiar. This equation represents the equation of an ellipse. So this activity was all about kind of showing you how do you go from a circle to an ellipse and where does this a squared and b squared come from? And that actually comes from how you're stretching the radius in 2 different directions. Okay, and then there's another part to it down there. So this is the standard form of an ellipse. You can ignore the h and the k right now because the h and the k basically tell you how far it moves from the origin. But your a squared, whatever is, if you have an ellipse that is a horizontal ellipse, okay, your a squared, your term at the bottom, the A part represents the distance from the center to the main vertex. And your B squared, the B part represents the distance from the center to your co-vertex. All right, and we won't worry about the H and the K right now. All right, so this is what we started talking about on Monday. So it's good review. The major axis of an ellipse is basically, is this a horizontal ellipse or is it a vertical ellipse? Both of these are not centered at the origin, but this one, the blue one, represents a horizontal, okay? A horizontal ellipse has this green line is the blue ellipse is a horizontal ellipse and the green line is its major axis. So, a couple of points about that. It's symmetrical about this green line, and it's kind of like the diameter. And then these black points that kind of end the major axis are the vertices. Okay. We can also have a vertical ellipse, right? And then this blue dashed line is the major axis. And then these two points right here are the vertices on the horizontal. Sorry, I said it wrong. The vertical ellipse. Okay, so that's the major axis. The minor axis is the one that basically is not, not the major axis, basically. Okay, so in the blue, same two shapes. This is your horizontal ellipse. These are your two vertex. These are your co-vertices. They're also symmetrical when you draw the line across the minor axis. Okay, and then the same with this one. Yep. All right, so we're going to skip over that. All right. So if I take out this part, which my ellipse is shifted, okay? If I take out that part, you'll see that this, and we can ignore the red one. I don't know where to make the red one go away at, but if I look at this equation of an ellipse, okay, we have x squared over 4 squared plus y squared over 2 squared equals 1. This is a horizontal ellipse, okay? The vertex are at 4 and -4, okay? So that the vertex points come from our value that's under our x squared because this is a horizontal ellipse. Our co-vertices are at 0, or 0, 2, and 0, -2. And that comes from our 2 squared number here. Okay. There's another ellipse going on there, but sorry. All right. And then there's one more thing I want to show you. Which is the foci. Okay. All right. So I don't know how to get it to stop scrolling, so it's just going to keep scrolling for you. All right. So the distance of the major axis. So this is a horizontal ellipse, right? The vertices are at 5, 0, and -5, 0. So what is the distance of the whole major axis? How far is it from -5 to +5? 10, right? 10. All right. So if you think about that number 10, that's the distance of your major axis. It says it right there. If you think about these two green points that we're going to call focus points or foci, everyone loves that, okay? So we're going to focus on these 2 points right here that are in green. See if I can get this guy to stop moving. I can't. It just keeps moving. I don't know how to get it to pause. All right. So anywhere. Oh, I did something to it. Go back. There we go. All right. So anywhere, if you could get this guy to stop, which I can't, But basically, if you measure the distance from this green point to the black dot and then the black dot to the green point, and you add those two distances together, so that's what this is measuring. The distance 1 is from this green point to the black point, and distance 2 is from, well, they might be flip-flopped. They're basically the two distances here. This is distance 1 or distance 2. If you add those two together at any time, they're going to equal 10, which is the length of your major axis. Right? So that's what makes ellipses kind of cool, and that's how you can actually draw an ellipse, right? Is by taking these two focus points and taking a string of the length of your major axis and then basically rotating it about those 2 points. Does that make sense? Does this visual kind of make sense as it's going around here? So the distance from the two vertex is 10, and we call that the distance of the major axis. Also, if you find your two focus points and you take that distance of 10, then any point in the ellipse, if you add the two distances together, will be equal. All right. Oh, notice and wonder. All right. So this is just this point where you can, we can play with this ellipse that's here. And so right now this ellipse has a center right here. The center is at 2, 3. So it's not in the origin. So it's not order 1. But it does have the vertex is 5 points away from the origin this way and 5 points this way. And the covertex is 3 points this way and 3 points this way. So what they're asking you here is what happens if I make my major axis bigger? So what if I increase my major axis of my ellipse? What do you notice about the foci, the green points? They get further apart, right? Because you're making the distance of your major axis bigger. The distance of the foci is also bigger. What about, let's go back to nice safe, where were we at? 5? We were at 5. Okay, let's go back to 5. What if I change the covertex of my minor axis? What happens to my focus points? So the bigger the covertex gets, the closer in the points come. Right? Because you have to have that distance equal to each other. So the bigger basically the minor axis, the covertex, the second side gets, the closer the focus points goes in. So as you increase your major axis, the focus points goes out. As you increase your minor axis, the focus points go in. What happens if you make your vertex and covertex the same? If your vertex and your covertex are the same, then you get a circle. Because you're basically back to you are back to the equation of the circle. You're back to x squared plus y squared equals radius squared. Okay, and then your two foci become one focus point, which is the origin of your circle. So again, if you make your major axis bigger, the focus points move out. If you make your major axis smaller, the focus points move in, right? If you make your minor axis bigger, the focus points move in and out. Okay. Someone was also asking, I think it was you, Anton, like what happens if your ellipse goes the other way? Well, that's the case where if instead of having a horizontal ellipse, like so say we make this 3 and we make this 5, right? Now my major axis, now this is a vertical ellipse, and my major axis is going this way. It's vertical, it's no longer horizontal, right? So once whatever basically whatever vertex is bigger, that gets to be the major vertex in the vertex. And then whatever is smaller gets to be the co-vertex. All right. I think that's all I wanted to do out of here. Oh, yeah. Oh, this kind of just shows as you move the focus points out, you can see how your circle gets smaller because of the distance. Okay, and then, oh, look at that. You could make a cute pumpkin. Write the equations of the dashed ellipses and you can make your pumpkin. That's pretty cool. I didn't see that on there. Okay, so that's what I wanted to show you. I think that that just gives you a good visual of what an ellipse is and why we have all these weird a squared plus b squared equals c squared. No, that's not what I want. I would like your notes for Algebra 2. There we go. And we are in, this is chapter 9. That's crazy. Okay, so if you remember in your notes, how does this all come together? So in your notes, all of this information is in there, right? So we've got a horizontal ellipse, all right? And then we have, when you have your horizontal ellipse, your vertex are at negative a and a, well, a0 and negative a0. And that horizontal ellipse, the a value goes under your x. So that's how you know it's horizontal. Okay, and then we have your covertex at 0b and 0 negative b. That's what's under y squared, and then that equals 1. And so we kind of showed in that activity with Desmos how this equation came about, how it relates to a circle, and why it equals 1. Basically, you're dividing your a squared, b squared on every side of the equation. We also have our focus points, and we have an equation how to find our focus points. So we have a lot of information that we talked about on Monday. So what I'd like to do is I'd like to do one or two more examples just to make sure you guys feel comfortable with this. Okay, so what I'm going to do is I'm going to print screen this. Where did I want to go? Not there. Back to here. That's what I want. Okay. So we want to graph the equation and identify the vertices, the covertices, and the foci of this ellipse. I don't want that yet. I need to make this bigger. There we go. All right, so here's your equation. And we want to basically be able to graph this ellipse. Okay, so we've got 25x squared plus 9y squared equals 225. So what they've done here is they've actually written the equation kind of like our initial equation that we had when we were using Desmos. So what I'm going to propose is let's make this equation look like our two major equations that we have here. So we have x squared, both of them you'll notice equal 1, right, for our ellipses. So how are we going to take an equation like this and make it equal to 1? So let's divide everything by 225. All right. So what is 25 divided by 225? We don't want a decimal. We want this in a number. So 225 divided by 25 is actually 9. Okay. And 225 divided by 9 is 25. and all of that equals 1. So if I look at this, okay, I'm looking at this and I want to know, is this, the first thing I want to know when I look at an equation, is this a horizontal or a vertical ellipse? And I'm going to put this up in case you guys are chatting here. Sorry. All right, so is this a horizontal or vertical ellipse? Does anybody know just based off of this equation? Or have a guess? What do you think? Vertical? Yeah? Don't put the question mark on the end. Say vertical, because that's what it is, right? It's a vertical ellipse. How do you know it's a vertical ellipse? Well, we know because the bigger denominator, right, is under y squared. Exactly, Aaliyah. The 25 is bigger. Yep. And Olivia saw that the one under y is bigger. So because that 25 is bigger, we know that this is going to be a vertical ellipse. So that's our clue as to which one it is. All right. So we're dealing with this kind of ellipse. We know it's going to look like this. All right. So once we know that, and we know that this is kind of the general equation for a vertical ellipse, now we can assign some values. So we know that whatever is under x squared is b squared. So b squared equals 9, right? And a squared equals 25. So we've got that written out. So what that tells us is that we can now find out what the vertex are, because the vertex are just 0, a, which a squared is 25. So that means that a is just 5, right? So our vertex are at 0, 5, and 0, -5. Okay. Our co-vertex, right, are at b0 and -b0. Well, b squared equals 9, so that means b equals 3. So our co-vertex are at 3, 0, and 3, 0, and at -3, 0. Okay, and then our last thing that we need to find is our foci. So remember that your foci are this equation down here. It's kind of hidden. So your foci are at C. Your focus points are at C, and it's given by the equation c squared equals a squared minus b squared. So we're going to take our a squared, which is right here, and our b squared, and we're going to figure out what c squared is. So a squared is 25 minus b squared, which is 9, and that equals c squared. C squared equals 25 minus 9, which is 16. So that means c equals 4. So that means that our foci, our focus points, are at 0, 4, and 0, -4. Okay. So if you were to graph this without a graphing tool, I know you guys all have graphing tools, but you should be able to graph it. This is a pretty easy ellipse, right? If I draw my graph, oh, I want it to be black. There we go. If I draw my graph, 1, 2, 3, 1, 2, 3, 1, 2, 4. Okay. So you draw your vertex. You have a vertex at 0, 5, and 0, -5. Okay. This is your major axis right here. You have your co-vertex at 3 and -3. And you have your focus points at, I'll put them here in green, 0, 4, and 0, -4. So if you go to draw your ellipse, you're going to basically connect the dots of your vertex and covertex, and you're going to get a nice ellipse that looks something like that, right? Nice egg. Looks something like that. Okay, so I want to do number 3 just to make sure that we're all on the same page. Just trying to think. I think I should just start over. Let's do 3 and 5. So again, I'm going to pull this paper up because, like I said, you will be able to use this for your test. You'll be able to use your information here. So I'll give that to you. Number 4, by the way, is a typo. I have a typo on number. No, I fixed it. No, that one's okay. Somewhere there's a typo. But let's just start with this. Okay. So what if instead of giving you an equation, that's not what I wanted to do. What if instead of giving you an equation, no, still not what I wanted to do. Pressing all the wrong buttons today. Oh, goodness. That was my kids downstairs. I cannot hit any of the right buttons today. I will eventually be able to open this up. Copy that. Take here. Put it here. There we go. Close that. Okay. So write an equation of an ellipse with a center at 0, 0 that has a vertex of 7, 2 and a covertex of 0, 2. So they're giving you a vertex and a covertex, and they want you to write the equation that would map this ellipse. So if you look at this, you look at these points that they give you, the vertex and the covertex. Is this ellipse going to be horizontal or vertical based off of these numbers? You got your, picture right here to the right. Oops, that's not what I was trying to do. So it's going to be a horizontal or vertical. All right, Olivia says horizontal in the chat. I would agree with Olivia. Yep, that's right, Anna. It's going to be horizontal, right? The 7x, that's your x component, is bigger than 0, 2, which is your y component, right? So it's going to be a horizontal ellipse. So now I know my vertex is at A0. And I also know for this particular one, my vertex is at 7, 0. So it's kind of like a translation thing, right? I know that for a horizontal ellipse, oh my goodness, what am I doing today? What happened to my problem? There we go. All right. So, I know that I'm using this, right? And my vertex is at A0 and my vertex is at 7, 0. So that means that A equals 7. That's pretty easy, right? I know my covertex is at 0, 2, and in here my covertex is at 0b, so that means b equals 2. So if I wanted to write an equation with this ellipse, I'm just going to use this equation, which is x squared over a squared, which a happens to be 7, x squared over 7 squared plus y squared over 2 squared equals 1. Right, so now I've written an equation of the ellipse, and that's all I've had to do. if I would go to Desmos, just regular old Desmos, and type in what I just said, so what is that? Okay, I've got x squared divided by 7. Whoa. Gotta watch what you're typing. X squared divided by 7 squared plus y squared divided by 2 squared equals 1. Okay, so is this an ellipse with my vertices at 7, 0? Yes. And my co-vertex at 0, 2? Yes. So I'm good to go. I wrote the equation right. Okay. One more example, and I'll let you guys go. This is I guess the trickiest part of writing. So number 3, not a big deal. You can write that, right? What if instead we did number 5? Okay, so number 5 is an ellipse, and it has a vertex at 0, 8, and it has a focus point at 0, -3. So what kind of ellipse is this? Is this a horizontal or a vertical? So part of it's just looking at it, right? The vertex is at 0, 8. So that coordinate, that A coordinate is your Y coordinate. And so you know that this is going to be a vertical ellipse, right? It's going to be a vertical ellipse. So if your vertex is at 0, 8, you know it's going to be a vertical ellipse. That means that A has to equal 8 because your vertex is at 0, 8. Yeah, there you go, Leah. Vertical, right? The other piece of information they tell you is that the focus is at 0, -3. So one of your focus points, your C, is at 3 or -3. We're just going to say 3 because we don't need to worry about that. So if I want to write an equation, my equation has to be x squared over b squared plus y squared over a squared equals 1, right? If I want to write an equation, I need to know, I know my A and my C, I need to know what B is. I need to know what the co-vertex point is. So the equation is that C squared equals A squared minus B squared. Okay. Or I could rewrite this as, if I add B squared to both sides, B squared plus C squared equals A squared, or B squared equals A squared minus C squared. Okay. A is 8 squared. Sorry. 8. A is 8. So it's 8 squared minus 3 squared equals B squared. And if you do that math, you end up with 64 minus 9, which is 53, right? B squared equals 53. So if I wanted to write an equation with a vertex of 0, 8 and a focus of 0, -3, then my co-vertex has to be when B equals the square root of 53. So my equation then is, if I go back to my equation, it's x squared over b squared. So it's x squared over 53 plus y squared over 8 squared, which is 64, equals 1. So this is what your equation would be to have a vertex of 8 and a focus of 0, -3. Okay. So hopefully that helped make sense of kind of what an ellipse is, how it relates to a circle, why we have this random b squared and a squared, and why it's in this form. I appreciate you guys sticking with me today through all that. And let me know if you have any questions, all right? I hope you have a good rest of your day.